In figure, from an external point P, a tangent PT and a line segment PAB is drawn to a circle with center O. So let me read the question and tell you guys or show you guys what exactly the question is telling. From my external point P, so that's our external point P. Tangent PT is drawn. So this is a tangent. So making the radius and the tangent to subtend an angle of 90 degree. A line segment PAB. PAB is this. Is drawn to the circle. Okay. ON is a perpendicular to the chord AB. So AB is this. It's a chord. Chord is a line connecting from one end of the circumference to the other end. This is perpendicular to the chord. So a perpendicular line drawn from the center to a chord has a particular property. I'm giving you guys a second and a clue. Yes, it has a property that the perpendicular line will bisect the chord. So making this length to be equal to that length. Now to answer this question, we can go with your traditional all this, with all these expressions and everything, or we can use variables. For example, I'll call radius as R. So this also will be R. I'll call ON as say Y and AN as X and NB will also be equal to X. PO is playing a role over here. So we'll call this as H. Reason being, it's the hypotenuse of two triangles, two right angle triangles, that you guys can figure out which two right angle triangles. So let me start off the answer without drawing the diagram. But we'll have to mention that let radius be equal to R. Then we have the hypotenuse be equal to H. Then we have ON be equal to Y. And we have to explain that we have AN is equal to X. This implies therefore BN is also equal to X. Reason being ON is perpendicular to BA and perpendicular from the center bisects the chord. Close the bracket. Right? I think I took all the variables. Oh yeah. And also we have one more thing. PA. We can call this as not exactly required, but we'll just call it as A. Okay. So yeah, this is enough in your exam. You need not draw anything over here. You can write all of this using a pencil onto your question paper. So this will help us prove things easily. To prove, there are quite a few things I'm not going to write because it's a lengthy question and I need space and everything. Proof. So we have the first one. I'll start with LHS. See, I'll just write what is obvious. That is P into PB. So what is P and PB? Look at the diagram. PA is A. Okay, that's good. What is PB? It is a combination of A plus X plus X. That is A plus 2X. Right? That's it. Don't think too much. Then go with your RHS. So what are we looking at in RHS? Pn square minus An square. So what is Pn? Pn is A plus X the whole square. Right? Minus what is An? Oh yeah, we need to. Pn is a combination of Pa plus An. That we need to mention first. Minus An is a combination of, well, An is not a combination of anything. That's just X square. So on substituting, what do we get? This is A plus X the whole square minus X square. Okay. Now, so what do we have here? We have A plus B the whole square, which is, you guys know what is this. So using this formula, we have A square plus X square minus, not minus, plus 2X minus X square. and here we have x square, that is common, and we left out with a square plus 2x. What about this? This is also a square plus 2x. So this is equal to our LHS. So first part is pretty so simple, is it not? Right? We don't have to think much. Just go with the diagram and done. So most of the question, it can be done this way. Second one is a bit tricky. So we need the diagram actually. Let me. Yeah. For the second one, what do we have? Proof for the second one. Let's see what is that we have. We have Pn, okay, and An, right, is equal to OP, which is hypotenuse, and OT, which is radius. So the expression for the RHS is very simple. So let's write the RHS. So what do we have? In the RHS, we have OP square minus OT square. This is equal to hypotenuse square minus radius square. Very simple. Let's not complicate that. Next we have LHS. So what is that we are looking at in LHS? LHS is Pn square minus An square. Okay. So Pn is made up of no. Pn is made up of, if we go with that, it will be a bit lengthy. See, the point here is we have to relate it to hypotenuse and the radius. Or we can actually, you know what, we can simplify this further. Why? Please have a look at the other triangle being this. Let me color it for you guys. So let's consider this triangle. What is that we are looking at? Here we have the hypotenuse to be h, and then we have the base to be x plus a, which is combination of p, a and an, and we have y and everything. So it might lead to something, you know. Okay, let's go with this. So let me put it this way. Hypotenuse square from triangle OAN. So in triangle OAN, what do we have? We have hypotenuse square is equal to y square plus a plus x the whole square. We can expand it or just keep it. Let's just keep it. Then in triangle radius, right? Which triangle can we use? Not exactly that. That's your radius, remember? So we can make use of this triangle, is it not? So which is that triangle ONA. So we have radius square is equal to y square plus x square, and on substituting, so what is that we are looking at? We have RHS is equal to y square plus a plus x the whole square minus of y square plus x square. So what do we have? Plus y square and minus y are getting cancelled. That's good. And we have the same expression as a plus x the whole square is what? That's nothing but Pn square minus x square is An square. I think that's what we have to prove. Is it not? Right? And we proved it. That's it. So that's equal to our LHS. Is it not? Just have a look. Take 2 seconds. Very simple, right? With variables. Okay. And now on to proof 3. Guys, I was a bit skeptical initially about using variables to this extent, but honestly here things look very simple, and I'm writing little and I'm getting the answer. Is it not? So why not use this, you know? Right? So let me clear the diagram. And now what do we have? We have PA into PB is equal to PT square. See, we know PA into PB is equal to PN square minus AN square. and an square minus pn square minus an square is op square minus ot square. So think about it, you have the answer in front of you. Okay, let me explain it. So we have the LHS Pn into PB, PA into PB, sorry. PA into PB is equal to PA into P, where is B, is equal to an square minus Pn square minus an square, right? So that is from your equation, from your first expression. This is equal to P n square minus an square, right? And Pn square minus an square is equal to op square minus ot square. Op square minus ot square, right? Again, I'm just copying whatever is written over there. And op square is what from the diagram? Op square is, yes, OP is your hypotenuse and OT square is your radius. So this is equal to hypotenuse square minus radius square. And from the triangle, which triangle will I go with? Think about it, it's very simple. We have the following. Again, I'm using all the facts which we have proved till now. That's it. Not doing anything fancy over here. Please have a look. Yes. Since the radius and the tangent are subtending an angle of 90 degree using Pythagoras theorem, we can tell PT square is also equal to h square plus r square. Is it not? Actually, you need not write even this. This need not be even mentioned, but let it be. So then we'll move on to RHS. So we'll tell, what is it? P, I don't know exactly, PT square is equal to PT square is equal to radius square or hypotenuse square minus radius square. This is because of the following things. The reasoning is a bit lengthy. Let's write it. Because we have radius is perpendicular to the tangent at the point of contact, and also in triangle, this implies what? This implies angle. What is the angle? OTP is equal to 90 degree, and with Pythagoras theorem, we can write the above statement, is it not? And from above two things we can tell this is equal to LHS, and we have the answer. That's it. Okay, so this would be your answer. Yeah, I would suggest you guys to just go with this, calling them with this variable. If, to be honest, if possible, draw the diagram, because it will help the teacher who is correcting also to look at the diagram, and things are very simple. If not, technically you're not wrong if you don't draw the diagram for this question, because you are not doing any construction and anything. We are right, but actually 3 marker they do suggest you guys to draw the diagram. Yeah. Anyways, you guys have to draw the diagram. Draw the diagram, put the variables, and you have the answer. Right? Very simple using the variables. It's very powerful and it's very convenient. Right? It makes things a lot simpler to look at and answer.